Morning, grade sixes. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud. I hope you guys are really well this morning and looking forward to learning a little bit more about mathematics. Just a reminder of the email address on your screen, grade6@worksheetcloud.com. Please feel free to use it to send me any comments, suggestions, questions, queries. There might be something you'd like me to have a look at and go over, and I'll be more than happy to address that moving forward. So today we're going to be looking at sequences. On either side of that main theme, we've got our warm-ups, our mental arithmetic questions covering previously taught principles, and then our brain bender and finisher to end off on. Let's have a look at our warm-up for today. So you need to tell me the value of each flag and then the question mark at the end. A reminder to work slowly, methodically, check your work, and yeah, take your time. There's no rush, and then let's see how you guys get on. So I started on the fourth line, and we can see that on the fourth line, 1 is equal to 5 minus 4. Okay. Then if 1 is equal to 5 minus 4, we're going to know from the third line that 5 multiplied by 0 is equal to 0. So we know anything multiplied by 0 is 0. I can go to the top and have a look at 5 plus 1, and we know that equals 6. So America plus Brazil has got to be equal to 6. So I just need to go figure out on the second line how that's going to work. And if I've got Sweden as 0 and 0, then America and Brazil are going to have to be equal. So Sweden flags almost cancel each other out. So that's going to mean that America and Brazil are going to be equal to 3 each, because on the top line we can see that 3 plus 3 is going to be equal to 5 plus 1. Okay, then all that's left for us to do is to have a look at the multiplication series at the bottom. And if America's 3 and Brazil is 3 and Australia could be New Zealand, I'm not a geography teacher, so apologies. We know that that's 5 times 5. And now we get back to the commutative law of multiplication, which says you can multiply in any order, you'll get the same answer. So here it depends on the order that you're most comfortable with. 3 times 3 is 9. 9 times 5 is 45. Then 45 times 5 is 225. Or are you going to go 5 times 5 is 25, multiply that by 3 to get 75, and then multiply that by 3 to get 225. Alternatively, you could say 3 times 5 is 15, 15 times 3 is 45, and then 45 times 5 again. So you can play around with the order. Either way, you should get the answer of 225. Okay, I hope you guys managed to work through that. If not, press rewind. Go back, have a look, and make sure you understand before moving on any further. Okay guys, your 7 daily mental arithmetic questions are on the screen. They all cover past taught principles. And again, I'm going to remind you to take your time, to be methodical and logical, write everything down. Make sure that you check your work when you've finished your calculation, and let's see how you guys get on. 29,08 plus 392,97. That's your first question. Here we're just adding in columns, and we just add normally. And the key is to remember to carry when we need to line up the decimals always. And then, yeah, let's check your answer at the end. So that's going to be 9 and 2 is 11 plus 1 is 12. So that's going to be 822,05. Remember, we can take that answer of 822,05 and subtract either 429,08, that should give us 392,97, or we can subtract 392,97 and that should leave us with 429,08. So that's going to be our checking strategy. So let's subtract 392,97 from our answer and see if we get 429,08. So we know we need to borrow. Okay, so 15 minus 7 is 8. Okay, so 8's there and 8's in 429,08. 9 minus 9 is 0. Okay, so that's correct and that 0 is correct. We need to borrow again. So 11 minus 2 is 9. So we have a 9, and a 9. Don't forget the decimal. And then we need to borrow from the 8. And that becomes 11 minus 9 is 2. And we have a 2 and a 2. So that's all good. And then 7 minus 3 is 4. So there we can see 429.08. So our original calculation must be correct. Now I'm happy. I can move on. I don't have to go back and check that question again. And I'm confident moving forward. Second question, 6,5 to 9. Subtract 3,271. Okay, and we know we just subtract normally. We borrow where we need to. Sorry, 4. 12 minus 7 is 5. 4 minus 2 is 2. And 6 minus 3 is 3. And remember, the check is to go the opposite way. So 8 plus 1 is 9. And remember, we add because add is the opposite of subtract. 5 and 7 is 12. 2 and 2 is 4. 3 and 3 is 6. So happy days. I've checked. I can move on. I'm confident. Okay. Question number 3 is long multiplication. There are numerous ways in which we can do this. 72 times 51. So I could compensate and say 72 times 50 and then add another group of 72. I can double in half to say 36 multiplied by 102, to say 18 multiplied by 204, to say 9 multiplied by 408. And now I've got a short multiplication sum. So that's another option you can use. Or you could use the tried and tested column method if that's what you so prefer. And that looks like this. And we'll work this way out today. 1 times 2 is 2. 1 times 7 is 7. Remember the most important part, the placeholder 0, because we're multiplying by 50 now. 5 times 2 is 10. Carry the 1. 5 times 7 is 35. Plus the 1 is 36. I add them and I get 3,672. Okay, but let's check that answer against another method. And perhaps we're going to compensate. So we'll say 72 times 50. And then we need to say 72 times 1. But 72 times 50, I'm just going to say 72 times 5. And 70 times 5 is 350. Plus 2 times 5 is 10. So that's going to be 360. But then remember, I need to add that multiple of 10. And then I need to add 72 times 1, which we know is 72. And you can see quite clearly that 3,600 plus the 72 is going to give me my original answer of 3,672. Happy days. Let's move on. Okay, so question number 4 is short division. Okay, 9,612 divided by 3. Now the first thing I'm interested to find out is if that number 9,612, if it's actually divisible by 3, gives you a whole number as an answer. So my divisibility rule there is if I add 9, 6, 1, and 2, so the individual numbers of 9,612, and I get an answer of 18. Now, is 18 divisible by 3? Yes, it is, 6 times. So I know that my answer of 9,612 is going to give me a whole answer when I work it out. Okay, so that's just a reminder of the divisibility rule of 3. 3 goes into 9 3 times. 3 goes into 6 twice. It doesn't go into 1. It goes into 12 4 times. And then remember, our check is to go 3,204 times 3. So what I'm going to do is I'm going to split 3,204 up. 3,000 times 3 is 9,000. 200 times 3 is 600. 4 times 3 is 12. And if I add them all up, you can see I'm going to get 9,612. Okay? So again, our checking strategy has worked. We're confident in our ability to move forward knowing that we've got that question Correct. Addition of fractions. Notice that the denominators are different. So the first thing I'm looking at is your lowest common denominator of 4 and 3, which is 12. Okay, 4 goes into 12 3 times. So 3 times 1, which is the numerator, is 3. 3 goes into 12 4 times. 4 times 1 is 4. And that's going to leave me with 7 over 12. Okay, happy there. And then question 6, we're multiplying by a multiple of 10, and this time it's 1,000. Okay, we know that when we multiply, the number gets bigger. We multiply by 10, it gets 1 place bigger. When we multiply by 100, 2 places bigger. And when we multiply by 1,000, it's going to get 3 places bigger. So your answer is 1,908. And then question 7 is, what order do I do this question in? So we should remember that brackets always comes first. Okay, so this becomes 15 minus 10, and that is equal to 5. Okay, guys, I hope you guys are working through these problems as best as possible, and the solutions to your calculations are working out, and you're checking your calculations carefully. If not, go back, have another look, and yeah, like I said before, send me some feedback on that email address, grade6@worksheetcloud.com, to see if you need any additional help. Okay, so let's have a look at sequences. So in maths, we call a list of numbers in order a sequence. Each number in a sequence is called a term. So here you have a sequence of the multiple tables of 4, so the 4 times table. So obviously 4, 8, 12, 16, all the way to 32. So that's your sequence. The number 4 would be your first term, the number 8 your second term, the number 12 your third term, etc., etc. And you can see the number 24 is your 6th term. If the terms are next to each other, then they're referred to as consecutive terms. So 4 and 8 are consecutive terms. 8 and 12 are consecutive terms. 12 and 16 are consecutive terms. And then when we write out sequences, consecutive terms are normally separated by commas. So there's just a little bit of theory there for you to know and understand. So remember, sequence is a list of numbers. The numbers in the sequence are called terms. Terms next to each other are consecutive terms, and terms are separated by commas. We get infinite and finite sequences. Okay, so an infinite sequence is one that continues forever. So for example, the multiples of 10, well, the multiples of 10 go on forever. Okay, so that means that that sequence is infinite. And we show this by using 3 dots at the end. If a sequence has a fixed number of terms, it's called a finite sequence. Okay, so for example, the sequence of 2-digit square numbers, well, there's only 6 of them. Okay, so that's a finite sequence because it has a definite end. All right, so there's the difference between finite and infinite sequences. Finite, they end. Infinite, they don't end, and indicated by 3 dots at the end of the sequence. So some sequence follow a simple rule that's really easy to describe. And an example of this is, as you can see, the sequence in front of you, all we're doing is we're adding 3 each time. So sometimes that's really easy to identify. And we can also see that the numbers in that sequence are 1 less than a multiple of 3. So 2 is 1 less than 3, 5 is 1 less than 6, 8 is 1 less than 9. Okay, so it's going up in 3s, and the sequence, the numbers are also 1 less than its corresponding 3 times table. Other sequences can be completely random. Okay, so the sequence of winning a raffle ticket in a prize draw is completely random. In maths, we are mainly concerned with sequences of numbers that follow a rule. Okay, so let's have a look at naming sequences. So here are some names of some sequences which you might know already. So you know 2, 4, 6, 8, 10 is a list of even numbers or multiples of 2. 1, 3, 5, 7, 9, you guessed it, is odd numbers. 3, 6, 9, 12, 15 is the 3 times table. That's going to be the 5 times table. What's that going to be? That's square numbers. Okay, so 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 6, and so on and so on. And just make sure you notice that all these sequences are infinite because they've all got the 3 dots at the end. So even numbers go on forever. Odd numbers go on forever. Multiples of 3, multiples of 5, square numbers go on forever. And your last list there is triangular numbers. So triangular numbers, if you don't know, are numbers needed to make a triangle. So that starts at 1. Then we need 3 dots to make a triangle. If we want to make the triangle bigger, the next step is 6 dots. If we want to make that bigger, the next number is 10. Okay? And again, that's infinite, and that's indicated by the 3 dots after the 15. Next thing we're going to look at is ascending sequences. Okay, so ascending is smallest to biggest. When each term in a sequence is bigger than the one before, it's called an ascending sequence. So again, smallest to biggest. Okay, so here's an example of an ascending sequence. So you can see all the numbers are in order from smallest to biggest, and the sequence increases in equal steps, and all we're doing is we're adding 5 each time. Okay, so that is indicated on your screen right now. And again, make sure you notice it's an infinite sequence with the 3 dots at the end. The terms in the second ascending sequence, they increase in unequal steps. So you can see that first it goes up in 0.1, then it goes up 0.2, then 0.4, then 0.8, then 1.6. So what you need to recognize there is that each term is multiplied by 2 to get the next term. Okay, so your first one, increasing by 5 each time, those will equal steps and relatively easy to identify. The second one, they're not increasing in equal steps, but you need to identify that you are multiplying by 2 each time. We also get descending sequences, which is obviously biggest to smallest, okay? And again, you get equal steps. So here you can see we subtract 7 each time, okay? And yes, sequences can go into negative numbers. So just remember that the larger the negative number, the smaller the number actually is. And the best way to describe that is using a temperature example. Minus 25 is a lot colder than 24, okay? So try remember that when dealing with negative numbers. And we also get descending sequences that decrease in unequal steps, okay? So here you can see first we decrease by 1, then we decrease by 2, then by 3, then by 4, so on and so on. And what you need to recognize there is that you're decreasing by 1 more each time. So you would be able to continue that sequence by subtracting 8, then subtracting 9, then subtracting 10, and so on. Okay, we're going to just have a look at describing a few sequences. So the first set we're going to look at is geometrical patterns. So we can show many well-known sequences using patterns. Okay, so even numbers we can show using something like that's on the screen at the moment. We can use geometrical patterns to show odd numbers, as seen on the screen, okay, and that just sometimes makes it a little bit easier for us to understand how that sequence or how those numbers are growing. We can also use it for square numbers, okay, so there you can see how each shape grows each time and how the numbers increase each time, and quite often having a visual representation of a sequence actually makes it a lot more easier to understand, okay. And then triangular numbers, which is what I explained earlier, is there you have 3 circles to make a triangle. I then need 6 to make my next triangle of the bigger size. Then I need 10, and then I need 15. And you can see it goes up by 1 more each time. So my next set of triangular numbers is going to be going up by 6. So 15 plus 6 is going to be 21. So that would be my next triangular number. So sequences that increase in equal steps. We can describe these sequences by actually finding a rule that tells us how the sequence continues. So to work out the rule, it's really helpful to find the difference between consecutive terms. Remember, consecutive terms are terms that occur one after each other when it's in order, or when the sequence is in order. So if we had a look at that sequence on the screen, 3, 7, 11, 15, 19, 23, 27, 31, you should be able to notice that the sequence starts at 3 and then increases by 4 each time. All right? So your rule there is going to be that you add 4 each time. And you can also notice that every term in that sequence is 1 less than the multiple of 4. So 3 is 1 less than 4, 7 is 1 less than 8, 11 is 1 less than 12, etc., etc. Again, an infinite sequence based on the 3 dots at the end. We could keep adding 4 forever, really. Okay, so here's one for you to do. Can you work out the next 3 steps in the sequence? And while I'm talking, I need you to work it out. So first notice, is it in order? Is it ascending or descending? What is it decreasing or increasing by? And by now, I'm hoping that you've realized that the next one is -8, -14, and -20, and it's infinite based on the 3 dots. And how did you work these out? Well, you should have noticed that we are subtracting 6 each time, okay? And that would be the rule, okay? Also notice that each term is 2 less than a multiple of 6. So 22 is 2 less than 24. 16 is 2 less than 18. 10 is 2 less than 12. And all those numbers are multiples of 6. Okay? This is really useful for you to be able to look at a number and, you know, the number 22, okay, it's even. It's obviously divisible by 2. It's in the 11 times table. It's 2 less than a number in the 6 times table. It's 1 more than a number in the 3 times table. It's just really good for you to get an understanding of what a number is and how it relates to other numbers around it. Okay. So this is really important. Sequences that increase or decrease in equal steps, they are called linear or arithmetic sequences. Linear because they kind of follow the same line, and you know they change in equal steps. Okay. Sequences that increase in increasing steps. So we know about the equal and unequal steps. So let's have a look at this sequence. So you should be able to notice, first of all, that it increases by 1, then by 2, then by 3, then by 4, and so on and so on. So, you know, you need to be able to recognize what would I add to 33? I would add 8. Okay, then I would add 9. Then I'd add 10. Okay, the difference. Okay, so this is important. The sequence itself is not linear, but the differences between the terms is a linear sequence. Okay, so you can see the differences make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. That's linear, but the actual sequence itself is not linear because it increases in unequal steps. So have a go, see if you can work out the next 3 terms in this sequence. And again, start off by looking, is it increasing or decreasing? Is it linear? Is it non-linear? And by now, I'm hoping that you've recognized that first we decrease by 0.1, then 0.2, then 0.3, then 0.4. So 0.5 back from 6 is going to be 5.5. I then need to go 0.6 back to 4.9, and then 0.7 back to 4.2, and I could keep doing that forever, is indicated by the 3 dots at the end. So how did you work these out? So that's pretty much how you would have worked it out. You would have noticed the difference between each of the consecutive terms, and with sequences of this type, it's often helpful to find out a second row of differences. Okay, so what do we mean by that? Sorry, that's the linear sequence of how much it decreases by. So even though the original sequence is not linear, okay, the difference between consecutive terms is linear. Okay, and again, it's just good to get a really good understanding of the sequence that you're working with and the relationship between the consecutive terms, and also the relationships between how much each term decreases by each time. So here we're going to look at a second row of differences, and you should be able to see here that looking at the difference of each term, we increase by 2, then 5, then 8, then 11. So it's 3 each time. So that's, at the moment on the screen, that's a nonlinear sequence. Okay, the original sequence 1, 3, 8, 16, 27 is nonlinear. It's increasing by different amounts each time. The actual increase, the numbers in red, are also nonlinear. Okay, so 2, 5, 8, 11. Okay, that's nonlinear. However, if we put a second row of differences in, then it becomes linear. Okay, so you can see it increases by 3 each time. So your second row of differences is indeed a linear sequence. All right, and there it says this shows that the differences increase by 3 each time. And I'm just continuing the sequence for you to get an understanding of the second row of differences. Okay. So we can also have a look at sequences that increase by multiplying. So some sequences increase or decrease by multiplying or dividing each term by a constant factor. So we've only just looked at adding and subtracting, and now we're going to have a look at multiplying. So if you have a look at this sequence, yes, you should be able to recognize that the number doubles each time. So 2 doubles to 4, 4 doubles to 8, 8 doubles to 16, 16 doubles to 32, and so on. So you need to be able to recognize that we're multiplying by 2 each time. Okay, so if you had to think about a general rule, you could say that multiply each term by 2. It's also interesting to note that each term in the sequence is a power of 2. So what do we mean by that? If I start at 2, 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3, or 2 cubed, is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. So you can see there's quite a lot going on in each sequence. And it's really, really beneficial if you guys can identify as much about a sequence as possible. Okay, and here is a sequence that decreases by dividing each time. And you would be quite correct in thinking that we are decreasing by dividing by 4. All right. And there you can see the division of 4 each time. And you're more than welcome to go and work those out. But yeah, we divide by 4 each time. So sequences can change by adding, subtracting, multiplying, and dividing. You could also say that instead of dividing by 4, we could have multiplied by a quarter, and that's exactly the same as dividing by 4. So 1025 multiplied by a quarter is 256. Because remember, when we multiply by a quarter, we divide by the denominator, which is 4 anyway. Okay, so there's an added insight into that particular sequence. This is called the Fibonacci sequence, and Fibonacci was a mathematician many, many years ago. And I'm going to leave this on the screen for a couple seconds to see if you guys can work out the next 3 terms in the sequence. 1 to get 2, then you add 1 and 2 to get 3, then you add 2 and 3 to get 5, then you add 3 and 5 to get 8, 8 and 5 to get 13, 13 and 8 to get 21, 13 and 21 to get 34, 34 and 21 to get 55, and then you would have 55 and 34 to get 89. So that's the Fibonacci type sequence. That sequence appears everywhere in nature. And what I'll do is in one of the next few lessons, I'll actually put on a Fibonacci lesson so you guys can see the amazing and wonderful things that you can see in nature regarding mathematics. So how do we work this out? I've explained that already, and there it is for you in writing so that you have something to refer to. and you know that the sequence starts with 1. And then, yeah, I've already explained how you get the next sequence by adding the previous 2 consecutive terms. So there it is, the Fibonacci sequence, named after the Italian mathematician who first worked it out and first wrote about it. Cap. So here are some sequences that you might come across. So first of all, we spoke about sequences that increase or decrease in equal steps, and they're called linear or arithmetic sequences. So that would be like 2, 4, 6, 8, 10, always increasing by 2, or 1, 2, 3, 4, 5, 6, 7, always increasing by 1. We get sequences that increase or decrease in unequal steps by multiplying or dividing by a constant factor, and that constant factor is like you always multiply by 2 or you always divide by 4. You get sequences that increase or decrease in unequal steps by adding or subtracting, increasing or decreasing numbers. So we looked at the Fibonacci sequence, we looked at the triangular number sequence, and they increased in unequal steps, and they were by adding. And you can do the same by subtracting. And then we looked at sequences that increase or decrease by adding together the 2 previous terms. So they're particularly the Fibonacci sequence. So those are some of the sequences that we looked at today. Really, really important concept for you guys to grasp and understand as you know sequences continue moving forward in your school career, and they tie in quite nicely to algebra. So eventually you'll actually work out formulas for sequences, and if I say to you what is the 100th term in a particular sequence, you're not going to want to have to write out 100 terms. You're going to want to figure out the formula for working out the number of terms, but that's something you can look forward to in grade 7 and grade 8. That leads us on to our finisher for today, and that's the game of 24, which I'm sure you guys are fully aware of how it works. If not, use each number on each card. So for example, on the first card, you've got 2, 6, 6, and 5. Can I use those 4 numbers with add, subtract, multiply, divide? You don't have to use all the operations. You can use 1, 2, all of them, 3 of them. But you need to come up with the answer of 24. Okay? And you need to do that for each card. And then the second part of the challenge was, how many different ways can you come up with the answer of 24? Grade 6s, shot for joining me today. I hope you learned something. Please keep an eye out for the online activity with the accompanied memo for you to consolidate the information we've learned today. Remember to send me an email with any suggestions or queries. I hope you guys keep safe, keep well, and I'm looking forward to seeing you next time. All the best.